Now on to part 2 of 9.2, where we're using the same setup, but we're solving the problem a little bit differently. This time we know that this outside line is a tangent line. The problem tells us that point B is a line of tangency. We can find the radius r using the Pythagorean theorem. We're going to set this up just like we did the last problems. Remember that C has to be our hypotenuse. So if we remind ourselves where the right angle is in our triangle, we can find our hypotenuse because it's across from the right angle. C here has to be this side that I'm going to highlight in pink here. This line is broken up into 2 different pieces, so we have to be careful how we write down how long it is. Your brain might see the 50 that's right here and say, this side must be 50. But that's not quite true. In this picture, 50 goes from here to here, but we also have a piece of the line going from here to the center, which is r long. To get the length of the whole line, we need to add those 2 pieces together. So our side C is 50 plus r. The other 2 sides are a little bit easier. B, I will color code in blue. This side, pretty straightforward. It's 80 long. And finally, side A is our radius. It's our only leftover side here. That side is r. Next, we need to plug in these numbers into the Pythagorean theorem, just like we did on the previous problems. We'll put an r in the blank here, an 80 in the blank here, and a 50 plus r for the hypotenuse. We're going to simplify again by squaring all of our terms. Working from left to right, we'll start with this r squared. R, when you square it, turns just into r squared. 80, when we square it, I'm going to type into my calculator. That gives us 6,400. And then on this right side, we need to be careful. We need to FOIL these terms. To make it a little bit easier to see what I'm doing, I'm actually going to rewrite this part first. Instead of writing it as 50 plus r squared, I'm going to show what that square means by writing it out as 50 plus r times 50 plus r. This will help make sure that I'm not missing any pieces. The left side, we already simplified a bunch, so I'm just going to carry those pieces down. R squared plus 6,400 equals. And now here is where we need to remember to FOIL. Remember that FOIL in algebra stands for first, that's the F, outer, that's the O, inner, and last. You might also remember it by these kind of little curvy lines. So first we need to do 50 times 50, which is 2,500. We need to do the outer, so 50 times r, so plus 50r. We need to do the 2 inner terms, which are 50r. And we need to do the last terms, r times r. That gives us r squared. Foiling. This is why I like to write out both pieces, 50 plus r times 50 plus r, because it makes sure that I'm not going to forget any of these middle guys. Next, we can combine some terms. The left side, we're still leaving alone for now. But on this side, I see a term with an R and a term with an R that we can combine. 2,500. 50R plus 50R is 100R. And we have an R squared left over. Nice. Now we can start looking at both sides. I see something that can cancel out on both sides, and that's this R squared. I'm going to subtract R squared from both sides of the equation to get rid of it. On the left, we're left with 6,400 equals 2,500 plus 100R. We're almost done. We want all of our plain numbers on the same side, so I'm going to subtract 2,500 from both sides. This leaves me with 3,900 equals 100R. And our last step is just to divide by 100. I get 3.9 equals R. See if you can do the practice problems following these same steps. Make sure you don't forget to FOIL.